Hi all, welcome back to our channel Vision Board, and today this is the continuation of the asymptotic notation or asymptotic complexity. So in the previous lesson we already discussed about this asymptotic complexity is divided into this is divided into three categories. The first one is big O. This is theta and omega. Okay, so here we will discuss about the big O notation. So I will tell you how it will be happen. So the big O notation means it helps to measure the performance of any algorithm by providing the order of the growth function. So big O notation is the measure of the performance. Okay, measure of the performance of any algorithm that provide the order of growth function. It gives upper bound on the function by which can make sure that the function will never grow faster than the upper bound. This point is some confusing, okay, that I will explain easily. So we'll explain. So we will calculate the upper. Normally what we can do, normally we are not taking any algorithm, we are just calculating the program, how many time it consume, and then an approximate value we are finding out, right? That is our A. So bigger notation will help to achieve the same. So we are finding the approximate runtime rather than the exact runtime. Approximate runtime means if you are writing a program, okay, then based on some guidelines and our understanding, what we are doing, we are neglecting some of the terms. That means the constant term we will neglect, and also the lower order terms also neglect. Then the remaining we will consider. So that is the one consuming the most of the time. So it is like a approximate runtime. Nearly it is equal to actual. You already see here, right? In the number of input is increasing, the percentage of time also increasing. Here it is 1000, right? 1000 it will be 99.88% time is consuming this one. This and this is negligible as compared to this value, right? So we can only consider this one as a practical example. So I will tell you how we can calculate this one. If f of n, okay, f of n and g of n are two functions, then f of n equal to omega of g of n. That means time complexity of f of n equal to, that means how we can find the omega sign of g of n we are taking. Then we can get the time complexity of f of n. If there exists a constant is c and n0, that's condition c and n0 is there. So our equation will be f of n less than or equal to c into g of n. Okay, that means the function f of n never will exceed, okay, always still in the under of the c into g of n. So for all n greater than n0, that I will explain. This simply means that f of n denote the grow faster than g of n. Does not grow. F of n always does not grow faster than g of n. So how worse the algorithm can, that means how worse the algorithm can perform. That means if, for example, what you can do, I will tell you here. I will tell you x. So for example, f of n equal to n. N means what function? That means function of n means it is increasing. This is the linear function, right? So x equal to y. So this is the function. That means time increases. What happens? Time or n increases. N increases. The time also increases. That means this program, if we write this program, it has the worst time complexity. Means number of input depends upon the number of input, the time also increasing. That is, we cannot allow. We need to find out some easy solution to reduce the time. So this is the worst case, this kind. So for example, f of n equal to n and g of n equal to 2n. Okay, so if f of n equal to omega of g of n, that is our confusion. So f of n, we implemented our equation f of n less than or equal to c into g of n. And then you f of n value is picked here and g of n value also implemented here. N less than or equal to c into g. Normally from this equation we already know, right? N and n 2n is greater than n. Already we know. So this function is graph is grow linearly. That means it worstly perform, right? Depends upon the time graph also doing. If it is a good graph, what will happen? Depend upon the input, it will be like this or it will be like this. Not this. This is the perfect one because there is no impact, not much impact on the program. Depends upon the input. That means less time. So that we need to achieve. I will tell you one more example. You can see here. F of n equal to n plus 1 and g of n equal to n. But the first side we know g of n is less here because here 4n and 1. Here what? Here it is 4, right? So what will we can do? We can do, there is one thing we can do. Okay, this is n, not 4, this is n. Okay, 4n plus 1, this is n. Always we first look, we can know 4n plus 1, that means function of f of n greater than g of n. But what is our case? F of n of less than c into g of n. So if we give f5 constant equal to 5, what will happen? It will be greater, right? So that we can give here. That means 4n plus 3 less than or equal to 5n. Then 5n here minus, so n less than or equal to 3. That means for all n greater than 3, what will happen? F of n, the function is perform the worst case. That means f of n growth rate will be omega of n, but also linearly grow. That we can know. So this is the one we can get from this omega notation. So the next part I will deeply discuss about how it to perform, what kind of operation we can do. That we will discuss on the next lesson. I think hope you all understand this concept. If any doubt, comment it below. I will help you to solve those things. Okay, yeah.